let's talk about copper. How many times do you think you've used copper already today? What's my audience think? All day? Yeah. Any numbers? Yeah, maybe a few times? Yeah, dozens if not hundreds of times. That's right, we've got a mobile phone being held up. In fact, the standard household would probably use discrete uses of coppers hundreds of times in a single day. And that's why it's the most unseen but critical metal that doesn't get talked about as a critical mineral, but in fact it is. As you've just heard, I'm Lee Staines, founder and managing director of Banksia, and we're here to talk about redefining the future of copper production. So we're at a very interesting point in time in the copper supply chain because for a number of years it's been talked about the fact that copper demand is exponentially soaring, but supply hasn't really been changing. And in fact, 2025 is the year that's been talked about for a long time as being the critical junction of this. And it's something I was very aware of coming from my former employer, Rio Tinto, because both Rio and the world's biggest miner, BHP, have openly talked around their number one business challenge is copper supply. So where's all this demand coming from? Well, as you've already heard today a number of times, copper underpins the energy transition. It's used in everything from energy generation, transmission, and of course, all of those many electrical devices that we each have. But it's also used extensively in transport, in building infrastructure, and throughout households. And more, we're getting demand for use in computing applications, all of these applications of AI, and of course, what sits behind that is the computers and the data centres that need to support them. So we've just heard Steve Kessel talk about all the amazing businesses that Amazon has built. Every single one of them required copper to develop. Copper is not just a mining story, it's part of absolutely every story. So if copper's so needed and actually the price of copper has gone through the roof recently, it's at all-time highs, why don't we just go out and mine more? Well, the reality is that there's no shortage of copper. In fact, we have loads of resources in the ground, but they're called resources and not reserves because they're not actually viable to produce. And in fact, more than half the copper in the ground can't be put through standard processing, conventional processing methods. So when I met Professor James Vaughan at the University of Queensland Hydrometallurgy Lab, I was very intrigued to hear that they had a new solution, a far more versatile process for producing copper. We're very excited to introduce Banksia's process, which is really a way to look at a new paradigm for copper production. For a start, we're able to handle standard concentrates, but also a range of much more complex mineralogy. In addition to that, there's loads of benefits around it being a far smaller facility. It needs many less people to run, and so it's a fraction of the capex and a smaller opex to be able to run this facility. It also has no off-gases. We end up with stable solid waste materials that are easier to dispose of. And it's a genuine pathway to being able to bring value-added processing back to in-country, like Australia, to be able to take things from ore bodies through to full product development. Does this sound a little bit too good to be true? Because I come from industry, and when they told me about it, that was my reaction. I went and spent a bit of time in the lab, spent a bit of time with the team, and what I learned, because when I did chemical engineering, we didn't do hydrometallurgy because that was with the mining engineers, was that actually for over 50 years, hydrometallurgy has been seen as the key to low-impact copper production. And in fact, back in the 1970s, chloride leaching was seen as the holy grail of copper production. So the team at UQ have actually had a breakthrough that's unlocked this to be able to be taken forward. And that's really the underlying technology behind the Banksia process, which is their patented electrochemical cell. Now, if we look at traditional smelting, we take copper concentrate. It's essentially ore that's been crushed up and concentrated because copper's in extremely small amounts when it comes out as dirt. And we put it into a smelter where it's burnt, melts, we form copper anodes, they get sent to refining, and ultimately we end up with a product called copper cathode. It's quite a lengthy and expensive process and involves really, really big facilities. By contrast, the Banksia process doesn't need any extremely high temperatures, there's no molten metal flying around, and as I mentioned, no toxic fumes. We simply dissolve the concentrate in very, very concentrated salt water, and then use electricity to electrowin the copper out of the metal. And this is what the breakthrough technology has unlocked, because traditionally people have been able to do amazing things with leaching minerals, but they haven't been able to extract that metal back out of solution. And with the cell design, the team has actually cracked the code on the ability to do this. Now, the concept of taking a supply chain that's in decline and turning it around to a production boom is actually not new. And in fact, the most recent place we saw it was with the US shale boom. So if you recall, over the 20th century, the US was a strong building the oil and gas industry. It's one of their leading industries and still seen as so. But actually, around the 1980s, it started to go into decline. And it wasn't until the mid-2000s that a couple of new technologies combined together unlocked shale oil and ultimately shale gas. And the US went from being a net importer of oil to, in fact, being the world's largest producer and a net exporter of natural gas. And this is where we see Banksia potentially being the new norm for copper and ultimately following a similar trajectory using known and accessible resources. Our vision is decentralising the copper production. For those who are a little bit familiar with the mining sector, you may be aware that more than half of the smelting capacity is located in China, and that's where most of our concentrate gets sent. And of course, we only have 2 smelters in Australia, and one of them's currently been announced to be shut down sometime in the next 5 years up at Mount Isa. So we've been in discussion with the copper operators and state and local government up there around what would our operating model look like if we were to build a Banksia facility. Now, one option is we could make a much smaller fit-for-purpose facility located centrally. The current smelter is more than double the capacity that's needed in that region. But the other option is, because we have a modular design, we could actually build a number of plants that were out closer to the mine sites and reduce transport and logistics cost. And so this starts to introduce some quite different ways of moving material around the regions. And in a place where roads and pipelines are very expensive, not to mention power, these things start to make a big difference to the viability of these projects. And that's what Banksia is really all about. Yes, we could go in and replace smelters, but what we're really seeing as the value proposition and where we're getting the pull from the market is that we can unlock resources that are not currently able to be brought to market and really address this gap in the supply chain. So looking ahead, where are we up to? Well, we've been engaging and had a lot of interest from both the global players and local players, and we're testing a range of concentrates to really firm up and validate our different opportunity statements. Looking forward, we've done the engineering work at a concept level around our pilot plant. I've got it on a computer outside if you want to have a fly around and have a look with me later out in the expo. But we're looking at taking this forward to build. And so if you'd like to know more about what we're doing to address the supply gap and build a new copper supply chain, please come and talk to me outside. Thank you very much.